Our first speaker is Yingzi Lin, professor here at Northeastern of Mechanical and Industrial Engineering, director of the IHMS laboratory. And Yingzi Lin is talking about like novel objective pain assessment tools, which is certainly very important work as we all want to understand pain better. Thank you.
Thank you so much, and special thanks to Frank to organize such a wonderful event for all of us. And thank you for inviting me here to be talking. This is something I've been working on, I think a little over 10 years now, so I'm really ready to share with you what we had fun. Before I do that, just want to show you, it's not advancing. Okay, just want to give you a quick video that actually my capstone students videotape for me. Is there sound?
Hi, COE. Welcome to our lab.
Okay. Can we have the sound a little bit louder? Let me see if I can do that from my end. Hopefully that works.
Hi, COE. Welcome to our lab. So if you want to follow me this way to where we do all of our experiments. If you could sit down in this chair and sign the form.
Great.
And then if you could fill out this center questionnaire, it's going to be the German experiment questionnaire. So the experiment's going to consist of about 60 minutes driving in the simulation, and you're going to be driving through rural, urban, and suburban environments. All right, Jose, you're done with the driving part of the experiment. So if you could use your right hand to fill out the post-experiment questionnaire right here. Thanks so much for your time.
Thank you.
Thanks for coming to our lab.
Bye.
So that's what we do in my lab. Sometimes students come to me and say, hey, I want to play. Can I join your lab? And I say, yes, we develop games. We play all day. I think that's mostly of our life. And this next video, I just want to give you a little bit of flavor about what we are collecting in terms of data. So that's my PhD student, Varsha, over there. And we play with all the sensors, physiological sensors. We do eye tracking. We do brainwave signals. And we also collect facial expression to see how we can combine with other things. So usually I get more male participants than female because they don't want to mess up their hairs whenever we want to apply EEG. Personally, myself, I hate it every time they mess my hair. But as a token, we always give them shampoo and conditioner after the experiment. So that's been something you can tell that we do a lot of driver simulation. We try to detect driver states, fatigue, drowsiness, and very proud to share that we actually had the very first PhD dissertation in road rage detection in the world. So, and over the years, I've been also collaborating with, this one was with Tufts. We use, in a different domain, we try to see if we can quantify patients after stroke. So usually, as you know, this was done in a very subjective way, and basically based on questionnaires, all of this. So that was our very first attempt to see if so what we did is that we actually brought those patients to our driving simulators and have them perform a certain well-designed task. And this way we can quantify how we can provide recommendations to their clinicians and let them know what our assessments are. And this was partially supported by NIH. I also we played a lot, as I said. We also work with a lot of other places. Boston Fire Department was one of them. And in this one, we collect similar signals as you have seen, particularly brainwave signals, but instead of giving them any clinical recommendations, we actually offer them advices in terms of how they can use their PDA and what kind of interface should be designed so that we can find a match between the firefighters' cognitive load and things like that. So I think a little bit background about what I've done in terms of my research journey. By training, I'm a mechanical engineer, but I'm pretty sure that when I was hired by Northeastern back in 2005, 21 years ago, they hired me as an industrial engineer. I'm pretty sure about that. So we are a mechanical and industrial engineering department, so I think this actually was perfect for me. I was able to advise students in mechanical engineering, industrial engineering, and I put them together on the same project, and students learn so much from each other, given their diverse background. So what I'm going to share with a little bit detail about one of my research areas is pain assessment. And how do I get here? So far, we've spent a little bit over 10 years from now. This happened in a conference when I met with Dr. Yan Xiao on the right over there in one of our Human Facts annual meeting. And we had lunch together, just like all of us. We didn't know each other. We sat down next to each other and we started talking. He was the patient safety, he was a director for patient safety back in Baylor, Texas system at that time. So I started talking, sharing my what I do, and he said, wow, are you interested in collaborating? Because he did see a lot of pain application. So we start talking. And a year later, I flew to Baylor and brought one of my students, and we started the first data collection in a PACU setting. And by then, we didn't know, it was funny that we did not allow to publish anything. We did not publish anything because what happened was when Dr. Yan Xiao told me that, hey, everything's all set and come and we can start data collection. So my students were there, and then when we were back to Boston a week after, we were basically 24/7 when we were there. We lived next to the hospital, and whenever there's patient, we went in there. So as soon as we came back to Boston, in Logan Airport, I remember, I got a phone call from IRB office saying, hey, let's have a talk. And what we missed was it was an unfunded project. And they did request an extra stamp on the IRB, which usually we do funded projects, but that was an unfunded project at that time, and there's extra approval needed, and we missed that. So that's how we started. But nonetheless, we had a lot of fun. And since then, I brought back to my lab, and the first project we did is a co-pain experiment in my lab. So that's the easiest pain model we had. Co-pain, especially convenient in wintertime, because we just have to put some snow or ice there to make sure it's 32 Fahrenheit, that's it. And moving on, 3 years later, we got our first 1.2 million NASA project, and we start serious testing in Brigham women's with my collaborator over there. As soon as we had all IRB in place, both Brigham women's and the Northeastern, this pandemic. So we had to pause the project for almost 2 years. When when we proposed the project, if you look at the one over there, the first one's facial expression. So we did intend to include facial expression, but as you can imagine, after pandemic, we were asked that, hey, mask on all the time for patients, and you were not allowed to collect any facial expression data. So that's a big change. So we try to adapt, and we had. So this was a lab setting. That's one of my capstone project. Actually, it's a very strict process in lab setting, but in a clinical setting, we learned great lesson. For example, I'm not sure if my students are here, but I can tell that the first day that they went to Brigham to test on the first patient, I got a phone call from my angry collaborator from Brigham Women's. Where are your students? They are 1 minute late. So my students being very relaxed in my lab. I actually did not criticize them even they came in late, but that was the first lesson they learned. And the next day, they made sure that they were an hour earlier before the patient arrived. So that's the first lesson we learned. But so everything was conducted at the Brigham Women's Medical Research Building, and I had great collaborator, and we came up with all these protocol together, working on QST, and we were able, except facial expression, we were able to collect EEG, eye movement, blood pressure, EMG, respiration, and blood pressure as well. So there were a lot of data. The first thing we did was to clean up. There was a lot of data. It took us months and months to clean up the data. And but we had great results. Some of the papers we have published so far. I know we are a little behind time, so I'll try to run very quick. And we got some interesting conclusions. I think overall, we were able to find out, for example, what are good indicators in terms of objective pain measurement. And are there any optimized combinations, for example, considering feasibility and also from scientific value, what would be ideal in a real clinical setting? And our goal is so we also compared 3 pain models, pain prick, pressure pain, and cold bath pain, to see are there any differences that in terms of different stimuli and all of this. So it was really a rich set of data that we are able to conduct a lot of research study and answer a lot of questions. I will be really quick since we are talking about a lot of brain signals today. So we are also working on, this hasn't been published yet, but we are working on this to see if there's anything that we can find out from all those signals. More, for example, we were able to conclude that there's no single brain region, because when we start the project, we look at literature. We did very extensive literature study in terms of what are good regions for pain sensation. So based on our data, we were able to see, hey, probably there's no specific region, brain region that exclusively that can be associated with pain. And also we were able to look at all those, I think our next speaker is my colleague, Babak. Probably there's a lot of connection in there in terms of network science and how we can link things together. And this morning, 2 of our students did excellent presentation about the app, and we actually also have a Compass app. The goal is to have a remote monitoring system in the future, so that the chronic patients can, instead of coming to their clinicians, they can do this at home testing. So that's the idea when we start to work on this Compass. It was done by one of my capstone team, actually, capstone project team over the years. So a lot of interesting process and improvement that we could be done. And we actually were able to link to a cold pain test and feed the data to the app and see what we get. With that, I want to thank my collaborators over the years. Without their collaboration, none of this work would be successful. I also want to acknowledge my sponsors over the years. Every bit of support that I got from them got me today. And if you are interested in this, we actually had one of the these featured in Nature Outlook. Feel free. That's my student over there who's in Irvine now, working a big biomedical firm today. That's something they put together for our pain research. So thank you, everyone, and happy to answer any questions.